Okie dokie, I think we are live. Hello, everyone. Let me just get my system here set up. Okay, cool. Okay, my face is showing up here and on the first slide, but cool. Hi, everyone. I'm Niels Ben Thielen. Let's let some folks trickle in. If you're joining from LinkedIn or YouTube, please give us a wave in the comment section. It's always nice to get a little activity on there. Hi, Igor. Good to meet you. Hi, Ravi. Okay, let's get started. So my name is Niels. I am the Chief ML Engineer at Union. Union is an end-to-end AI platform where we enable everything from data prep to model training to serving, and we provide workflows, and apps, and artifacts, many other nice services to enable your AI development. And yeah, just maybe just a brief preamble. I'm getting over a little bit of a cold or flu or something, so please excuse me if I kind of mute throughout this workshop to cough and stuff. I'll also be drinking a lot of water. So let's get started. In this workshop, we're gonna make a NotebookLM clone with open weights models. It's going to be a minimal clone, so if you've ever used the Google product called NotebookLM, it's not going to be, as nice at all, really. But what I will show you is how to put the building blocks together to convert essentially a PDF to a kind of a podcast that sounds pretty plausible. Okay. So first, who am I? Besides being in the ML team at Union, I'm also the open source creator of Pandera, which is a data validation library for data frame-like objects. This is a Python library. Also, one of the core maintainers of Flight, which is the open source orchestration tool that Union is built on top of. And for any of you folks who are not from a traditional CS background, I'm in that club. I came from biology and public health and wound my way over into this field. And my mission these days is to build open source tools and some closed source tools for data science and machine learning practitioners. So the rough outline for today's workshop is I'm going to jump over to the setup because there are going to be a few things that you may want to start doing if you want to code along. We'll really just be running through a notebook, collab notebook, and I'll be explaining the code, running some things, examining some outputs, seeing how all the Lego blocks fit together. So I'll spend a few minutes there. I'll then jump back onto these slides to give you a brief intro into compound AI systems, for those of you who are super familiar with this fairly new term. Part two will be to actually examine a pre-built kind of the pipeline and the entire system for you, but we'll hop on over to the Google Colab notebook, and we'll clone NotebookLM with Llama and Kokoro. This is a LLM and a text-to-speech model, respectively. And then the last part will be deploying the entire system into a serving app so that you can, share this with friends and family and whoever else, colleagues, so they can upload PDFs and play around with it for a little bit. And in the end, we'll just do some wrap up and Q&A. Cool. And if you're just joining us right now, please give us a wave. Maybe you can, as Ravi said, mention where you're from and maybe what your title or role is in your current company. Okay, so before I go into this first part, let me hop over to the GitHub repo. The GitHub repo is at Union AI OSS/NotebookLlama over here. I'll also just copy paste it into chat. Boom. Okay. This is your home base. The slides that I was just at is here. And we'll hop over to this example lab so I can kind of show you the end result by the end of the hour. If you want to run the notebook and code along as I go, first you'll need a GitHub account. Hopefully many of you will have that. Then you'll need a serverless account. So at Union, we offer a serverless platform. I'm already signed in and have an account, so I go straight to the dashboard. But if you click on this link right here, it is signup.union.ai. You should see a screen that looks like this. Go through the signup flow. It should take you through like a kind of GitHub single sign-on flow, and it should be free. You'll get $30 in free credits, which should be more than enough to run this workshop. Once you've signed on, you should see a dashboard that looks like this. And so that's it for the Union serverless setup. Let me zoom in a little bit here. The next step is to sign up for a Hugging Face account and create an API key. So I'm showing you the screenshot of my own account here. This is going to be used for downloading the model weights from Hugging Face. That's what we'll be using for our kind of model repository. And finally, if you don't have access to the Llama 3.2 series, so that includes the 3 billion and 1 billion parameter model, go ahead and go to these pages, and there should be a little kind of UI element here for you to ask for permission. I don't know how quickly they process these days, but hopefully you'll be able to kind of hop on in time. Okay, so that's kind of the initial setup. This is the collab notebook that we'll be going into. So if you're on GitHub right now, you can kind of click into here and poke around if you want. Last thing I'll do here is, this is the notebook. It's always useful to save a copy in Drive so that if you change anything, then you can kind of persist those changes on your own Drive. Okay, cool. So hopefully that was about 5 minutes. So hopping back onto the slides, part one is a brief introduction to compound AI systems. So here we're going to learn what the definition of this is and what the minimal architecture of NotebookLM or a NotebookLM kind of application that turns PDFs to podcasts might look like. So if you've heard of the term RAG or agentic workflows, so RAG would be retrieval augmented generation. There are all sorts of variants of this now. So you have like contextual RAG, you have agentic RAG, and then agents obviously is a very trending topic this year. It's apparently the year of agents in 2025. But actually, I think those like agents is great. It's a good metaphor. It's a good kind of construct for reasoning about these kinds of LLMs that can make decisions, and like lower level descriptions of them might talk about agents having access to or being able to shape the state machine of some, the state of a state machine. So how you traverse a graph and what nodes are available on that graph in the first place. So that's like a whole nother topic. I kind of want to sidebar that for a bit. Compound AI systems, I feel, it's a nice concept. It's a nice abstraction that kind of subsumes or encapsulates both RAG-like systems and agents, I would argue. So these are software systems that use mostly deep learning ML models as part of a larger system, which may include databases, vector databases, code interpreters, APIs, other tools and deterministic code to achieve some kind of goal that traditional software system might not otherwise be able to achieve. So on the left over here, you have a classic kind of feed-forward neural net. And this has been the emphasis of machine learning and AI development kind of during the AI boom for the last decade plus, I would say. And kind of after LLMs and transformers and the OpenAI kind of ChatGPT moment, I think people started using these foundation models to build systems that look kind of like this, where you have like neural nets kind of peppered across the software system. They might read and write to a database. They might make requests to or call a calculator tool. They might do search, so make a call to Google or any kind of API-based search engine. They might issue commands to a terminal, and they stitch all these things together to achieve some kind of objective. So like a clear example of this would be like a coding agent where you chat with, you have a chat interface and it builds a UI for you, or it builds a code base for you. The source for this concept of compound AI systems can be found in this Berkeley link. They had released a blog last year. I think it's quite informative. So now moving to NotebookLM as an instance of this case. Is it an agent? Maybe. Like you can maybe argue this based on the implementation, but at the very least, it is a compound AI system because, as you'll see in a bit, we're bringing together multiple different models of different sizes based on the use case, maybe of different modalities, and we're stitching them together to build basically an interaction where you can upload a PDF, you can chat with the docs. This part we're not really going to implement since that's something most people should be familiar with now. And then this part, step 3, is what we'll kind of build, generate a podcast from that PDF. So the minimal architecture here, and I would argue maybe not super minimal since it has an extra step, which I'll point out that may not be necessary, is you have a workflow here that pre-processes the PDF input that you upload. It writes an initial podcast script. And then this is what I think might be superfluous, but actually might be useful, actually, based on the kind of 5 evals that I've done of the rewrites. It'll take the original draft of the podcast script and then rewrite it with some additional prompting. And then finally, take that script and generate a podcast. In this case, we'll generate one with 2 hosts, or like a host and a guest. It's kind of unclear. And then we'll deploy a serving app that I'll show you in a second, where a user can upload the PDF, and then out pops the podcast audio. I just want to call out why this is multimodal and it is a compound AI system is for this part where we extract, we want to take out all the random artifacts in a PDF file that are not relevant to the script writing process. We'll use a 1 billion Llama3 model for this. This should be 3.2. And then we'll use a slightly larger one. Ideally, you would use a maybe 714 or 70 billion parameter one for this writing part. But for the purposes of our workshop, we'll keep it fairly small. Use the 3 billion parameter Llama model here. And then finally, we will use the Kokoro 82 million, I believe, parameter. It's a very small but effective text-to-speech model. Will you can give it kind of descriptions of the speakers, and they have like pre-trained speaker personas that you can select. I'll show you that later. So this is really what, if we call back to this, right? It's a very simple, kind of fairly linear sequential pipeline of using different models of different sizes and modalities to achieve something that, you know, couldn't be done with a single multimodal model very easily. So you could, well, I guess I can take that back. One could train a foundation model that does this entire task, right? But you know, who actually has the hardware and expertise to do that? It's actually arguably desirable in some cases to modularize things in terms of these, you know, software best practices of separation of concerns, have different modules do different things. One single foundation model would be awesome, but you know, not all of us can build these things. Before going to the workshop, I think I just wanted to highlight a few architectural good to knows about Union. What I'm showing here is a simple RAG pipeline, right? So you have a retrieve step and a generate step. One could implement this on the same substrate. So you could have, maybe you can get an EC2 box or some kind of piece of compute and do both of these steps in the same compute infrastructure. But the way Union works is it's built on top of Kubernetes, and each of these, the nodes in this very simple DAG, run in its own container. And this is important because we can now have node level resource isolation and security and data permissions and all this really nice stuff that you get when you have very granular control over where each node in your pipeline, in your DAG, runs. The thing that necessitates, though, is data flow. So if they're running in their different containers, if the retrieve step outputs the retrieve chunks of documents, it's going to need to serialize this and write it to some intermediary store. In this case, we use some kind of blob storage. So it works with S3, GCS, Azure Blob Store, any other blob store that has a compatible kind of FS-spec API. And then the generate step will deserialize that into the downstream container. I mentioned this just because a lot of compound AI systems have, as it's implied in the name, you have heterogeneous workflow requirements. So heterogeneous meaning the retrieve step may not use GPUs, but the generate step might use GPUs. Ravi, I'll get to your question in a second. So it's very useful and cost effective, cost efficient to be able to not use a monolithic compute environment for your entire compound AI system, and to be able to pick apart and choose what runs where. Ravi asks, instead of podcasts, can a text-to-speech model be used in real time with a notebook, say while the cells are running? Oh, that's very interesting. That would be possible. You would need to have a kind of a different, what I'm showing right now is kind of a batch system. You would need a kind of online serving streaming system that would do this. Although I'd have to like dig into the details of your question there. Okay, so part 2, we'll get to actually seeing this in action. So I'm going to hop over to my notebook. So again, just if you didn't see my preamble before, head over to the repo over here, NotebookLM, and below all this initial setup, click on this Open in Collab badge. Just to show you the end result, we have this Streamlit app that I made really quick. The result of this particular PDF, just remind myself what this is, the theory of ecological invasions and its implications for co-evolutionary dynamics. Same title. So the results of this has been cached, so that's why this took very, very quick to run. I don't know if you'll be able to see this, hear this audio, but I'm playing this right now. And the script, the transcript goes here. It's fairly short script. That's mainly a function of the context window, and like there are ways to extend the script using a model with a larger context window, and also different settings for how many max tokens you have an output. But generates a 3-minute, 36-second podcast. So this is our end destination by the end of this workshop. So let's try to get there. So first, in this notebook, I made some last-minute changes here. So let me know if anyone's running this, they run into any issues. So I'm just connecting to my notebook. If you run this first cell, all it's doing is cloning the repo and installing the NotebookLM little package that we've set up here. Take a few minutes or seconds, hopefully. Okay. Sometimes it will ask you to restart the runtime, but I guess didn't this time. Great. So now let's authorize this collab session to our Union Serverless account. Also, feel free to ping the channel if you're having any problems getting signing up to the platform. I can quickly message my team about that, see if we can fix it. Okay, so what happened there is it spat out a URL that I just visited with the code already kind of embedded, and you should see something like login successful into serverless. The next thing you should do is create a Hugging Face API key. So based on that instruction earlier, creating the access token here, you take that value and you run the cell. And in this input field, you should copy paste that value. I already have it, so I'm gonna go ahead and exit this cell, clear the output. And just for a quick sanity check, you can run union get secret. This is the command line, by the way, and just verify that the key is there. So that should be all good. The last setup step we're going to do is we're going to register NotebookLM. So just for transparency, we are currently in this NotebookLM directory, and the subdirectory, also by the same name with the underscore, has all the code and the union tasks and workflows that we need to run our application. So we'll dig into this as needed, into the details. There's a lot in there to unpack, but hopefully we can get through all of it. So you should see when you run this that you successfully register a bunch of flight entities. Cool. And for those of you who are confused, flight Union is built on top of Flight, so there are a lot of things that we use from the Flight world on the Union platform. Cool. Now we're going to define a Union remote object. This is our way of kicking off the workflows and tasks remotely on the platform. So here you can think of this Colab notebook as like a little REPL section where we're running these commands. And then we define some utility functions to just pretty print some of the output of these tasks. Okay. So the first step in our pipeline, if you recall back here, is we're going to pre-process the PDF. So actually, I'm trying to decide whether I've already run my account on this particular PDF. Let me pick a different file. So I'm going to go to archive. You can do a different file yourself. I'm going to go to subcellular processes, principles of quantum biology. Interesting. So I'm going to copy this link address, and I'm going to paste it over here. Fingers crossed the pipeline runs with this. Okay, so if you run the cell, I'm just printing out the PDF extraction system prompt. So what's going to happen is we're going to use the PyPDF package to just pull the raw text out of the PDF, which will contain all sorts of, PDF formatting artifacts. So we're asking a LLM to clean it up. So this is what a prompt might look like. By the way, a lot of this I adapted from Meta's NotebookLM, which is why the repo is called NotebookLM. So just want to give credit to them. So a lot of these prompts I kind of slightly massaged and modified just based on vibes for this particular workshop. You can read it yourself. It basically tells it not to summarize, only clean up text and make it nice and clean. Don't use markdown formatting, things like this. So hopefully this is running. You can go click on this URL here. Oh, it looks like I've already cached this part. Oh, no. Yeah. So I haven't cached it. It ran and it cached the output so that if I run it on this same PDF, it doesn't have to rerun all the compute again. But I wanted to introduce you to the Union platform. So this is where the executions view is. It shows you kind of the graph and a timeline view of each node in your graph. We can look at the deck here for the extracted text. And so we can inspect what just the raw extracted PDF text looks like. And this step that's in progress is using a GPU. As you can see here, we're not fully utilizing it, but just give you a sense of what this platform gives you. Gives you some very top-level metrics for each node. You can get access to the logs that are being emitted by this one task. And so while this runs, I want to take you through the code. So for some reason, I can't jump to the code from here, so I'm going to have to find it here on the sidebar. So we're going to go to NotebookLM, preprocess PDF. Boop. And I'll just expose this part. So here's the Python file containing the Union code that enables this entire pipeline. The system prompt is here. We're using the Llama 3.2 1 billion instruct model. And I'm going to go all the way down to the PDF to text workflow that we're running. So as you can see, this is a Python function. It takes in a PDF path, which is a flight file. You can think of this just as a file. And it outputs a flight file as well. So it takes in the PDF file, outputs a text file. When we decorate a function with @union.workflow, we're saying that this is a workflow. So it's kind of it's a DSL. It's our way to build dependencies between tasks. And what are tasks? Tasks are this extract text function and this preprocess PDF function. So if we go up to this extract text function, it's decorated with union.task with some arguments to the decorator that basically declaratively specify what compute is needed and what container is needed to run this function. So you can think of this, maybe if you've used AWS Lambda, it's just like an AWS Lambda function in a Python function, and you can just run it like a regular function. It also is strongly typed, so Union leverages Python's type hints to be able to like compile and examine the dependencies between tasks to like spit out an error if there's incompatible inputs and outputs. So nice things like this. And all this task is doing a lot of details, but all it's doing is extracting the text from the PDF. The next task, which uses, so we're just going to use the same image for all of these tasks just for simplicity. But the difference between extract text and preprocess PDF is preprocess PDF uses this construct called actors. And what an actor is it's a container that lives longer than the invocation of a single task. So you can reuse it. And this is useful because in preprocessed PDF, we're actually going to use GPUs. Yeah, for some reason I can't like jump to tasks on Google Colab. It's weird. But we're actually going to load up a 1 billion parameter LLM onto this, the container running this. So as you can see, we're logging into Hugging Face. And we are processing the chunks of the PDF file with the model that we've loaded. So the model we're loading is here, load LLM model, the 1 billion parameter one. And we're basically passing that in to the process chunk function, which is just like a helper function in this case. This Llama preprocessing actor is defined in the actors file, which I'll just jump into real quick just to show you. But this is very powerful because declaratively I can create this actor environment that uses one GPU of L4 type with 2 gigs of memory. And I'll say it's alive for 600 seconds. So I want to keep it up if it's repeatedly called, so I don't have to keep spinning up a container. Just hopping into the comments for a sec, or into chat. Dheeraj, the code is over here. Okay, cool. So we've defined other actors here. As you can see, there's one for the writer and rewriter, and there's another actor for the text-to-speech model. So here we're defining declaratively, I'm not an infrastructure expert or a Kubernetes expert, but I can request all these resources just in code like this. Okay. So at the end of this, preprocessed PDF returns the text file. And it looks like it's still running. Yeah, so one thing to note here is that these workflows are a batch system. So it'll take some time to provision the node, download the model, load it into GPU memory, and then run the function that's defined in here. Okay. So let me hop back into the notebook here. Oh, wait. Cool. So let's run this. And what this is going to do is it's going to just wait for this to complete. Hopefully it doesn't take too much longer. We don't have too much time here. Maybe for the sake of time, I will interrupt this and I'll actually process the PDF that I've processed before. So we can kind of fly through these code cells on my side. If you're running these notebook cells yourself, you'll have to wait. But just to show you, I've previously run this particular PDF file. So these were just output from cache, and so it doesn't rerun the computation again. So as you can see, the extracted text looks reasonable. It looks like there are a bunch of numbers at the bottom. This was probably like a table or some set of numerical values that it didn't process, but the writer will ignore these, as you will see. So the next step we're going to run is the write transcript step. And you can take a moment to read the prompt here. You can see what kind of podcasts I listen to. But this is basically saying, take the content from above and write a podcast script with 2 speakers. And you can kind of give them roles, right? And so if we run this, this should be cached, so it should output immediately. And so here's the raw transcript. Speaker 1 says, "Welcome to our podcast," comes up with a name, et cetera, et cetera. We can dive into the details of this particular file. So it's in the write transcript file over here. Let me pull this over here. And it's a very similar structure to the pre-processed PDF. We're defining the model we're using, the system prompt, some helper functions, and then the main action happens in this write transcript function, where we're using the writing actor that I showed you before that uses the L4 GPUs. This is some fairly typical transformers, Hugging Face transformers code, and yeah, that's pretty much it. You can take a look more deeply in your own time if you want. But to just show you what this looks like in the UI, right? We already cached this execution. So I'm going to go back to the source execution, which originally computed this. And we can take a look at the deck, which is just these static HTML reports. We can take a look at the output here. And then finally, or I guess the penultimate step is rewriting the transcript. So let's run these. So this actually will output a list of lists, right? And so we're going to write this to some kind of JSON format for the podcast generation, audio generation step to take in. So hopefully this should return fairly quickly as well. a little, flavor here is the rewrite transcript prompt just has a little bit more in terms of like giving the transcript a little more character, and giving each speaker kind of a persona. So here's the rewritten transcript. It's a little bit shorter. You could probably do a diff to just compare this from the original. But the last step, I'll step through some of the code here as well, just because this is kind of an interesting part where we have speaker 1 and speaker 2 descriptions. Again, these were taken from the NotebookLM repo, so I got to preserve the personality of these hosts and guests and whatnot. So you have speaker 1 who's Laura, speaker 2 who's Gary. Actually, there might maybe some discrepancies here because I think the Kokoro text-to-speech model has different names for these. But in the end, we'll grab the audio file and we can play it. I don't know if you can hear this, but anyway, so that should play the audio file for you. The interesting thing here in the generate podcast script is really these speaker descriptions. And this is dependent on the text-to-speech model that you're using. And so if I go down to the function that generates the audio, we're using this American female heart is the name, I guess, of the persona, and American male Liam. And so these are things that you can find in the Hugging Face, Kokoro, files and versions, voices. So these are all the different personas that you can feed into that as an input to get different voices out. And I think there are different languages as well. So I think B is, I forget what B stands for. I think there's French, there's like English, Japanese, etc. Okay. So, and again, all we're doing is we're defining these Python functions with these decorators that tell Union where to run that function. Cool. Hopping back to the notebook. The last part is a little bit tricky. We're trying to smooth this part out a little bit. But basically, we're going to create a Streamlit app that can run this entire pipeline that we just ran on this notebook. So all of this is actually encapsulated into this simple workflow. So we have another PDF to podcast workflow. This is the one that the Streamlit app is going to run. It's going to run all the steps and output the podcast with the clean transcript. So in order to do that, our app needs an API key to actually run the workflow from the Streamlit app. So in order to do this, we're going to have to create an API key using this command. I won't run it, but this will output a string that you need to store in a secure place. And just to make sure that you have it, you can run this get API key admin command. Take a few seconds. Wow, this is an unreasonably long time for this command to run. Okay, finally. Okay. And you should see something that looks kind of like this, serverless1, and then your GitHub username, and it should be NotebookLM workshop, actually. And based on the string, you can create a secret that contains a string called Union API key, and this will be used in the Union app definition here. So in this app.py file, you'll see basically an app configuration that will run our Streamlit app. It'll include our Streamlit code, which is contained in this main.py file. And again, you declare what secrets are in there, what resources you want to use, what dependencies in this image spec object are required in your app. So the Streamlit code is here. I'm not going to go through all of it, but fairly straightforward Streamlit code that allows you to upload a PDF and then renders the audio file. So once you have your secret set up, you can check with Union secret. And you should see something like this, Union API key. And so that's what's being used over here in this secret request. You should be set to run this cell where we deploy the app. Some funky stuff happens with async since Jupyter Notebooks use async, and this deploy app method also uses async. So sometimes some weird error messages that pop up. Don't worry about that too much. You can see the app definition in this first URL here. So you get a sense of kind of all the events that happened on the infra side and some logs. So it looks like the Streamlit app is ready. And you can finally go back to this UI here we saw at the very beginning. You can enter a link to a PDF or drag and drop a local PDF file. Okay, cool. That's pretty much it for the notebook kind of coding, building part of the workshop. Just want to hop back onto the slides here. So in part 2, we learned how to kind of build that workflow, that base workflow to begin with. And in that last part, we saw how to deploy an app on Union. Excuse me. So in summary, compound AI systems are basically a combination of different deep learning models, foundation or fine-tuned models, and you're combining them in interesting ways with traditional software systems like databases and code sandboxes and whatnot to achieve some kind of higher level objective. What we learned here with the Union is that it is useful in these kinds of systems to have container native orchestrators where you have this kind of node level isolation of the DAGs in your graph or the steps in your pipeline so that you can be more infrastructure aware and cost aware about where things are running, since a lot of these models do require GPU hardware. The larger ones, like the 70 billion one, Llama model, or even, let's say, the 671 billion DeepSeek model, R1 model, will require H100s and more. And finally, just a call out to open weights models. It's great to have these available. so that you can build these kinds of systems yourself without relying on an API provider or the model. Of course, you can use API providers. That does simplify things a lot. But if you're in an organization or a company that has certain requirements, be they for privacy or kind of model governance reasons, open weights models are a nice way to implement these systems. And before my voice gives out, just to give you a few flavor of a few things that you might try next, right? So this was really, what I showed you was the very basic proof of concept. This is to show you, hey, all the plumbing works. But if you play around with it, there are going to be a lot of issues with the final product of the podcast in this case. So these are a bunch of things that you would try. Defining evals, crucial. Creating an eval data set, refining prompts, experimenting with different models, collecting human feedback, doing error analysis, and seeing where the models or the system as a whole makes mistakes, and figuring out which part of the system makes those mistakes. And then finally, this is where you might fine-tune and serve custom models yourself if you have the hardware requirements. Here are some resources that might be relevant, some papers and blogs that you might want to look up that relate to what I just showed you in this workshop. And yeah, just want to close up now, and I'll stick around for a few minutes to answer any questions. The slides are in this short link, go.union.ai, workshop.NotebookLM clone. The code is in this repo, Union AI OSS Notebook Llama. You can reach out to me by email on Blue Sky or LinkedIn. And yeah, happy to take any questions. Thanks everyone for sticking around and listening to me. Curious of the people who are here, if anyone here is building anything of this nature, not this specific application, but kind of putting together different models for some kind of application. Oh, also, quick shout out, if you happen to be at GTC, okay, cool. Yeah, if you happen to be at GTC this year, we have a booth, so come look at us. Look out for us. I think our booth is 2022. If you're around, my team is there and would love to chat. Yeah, Ravi, the notebook is just for the workshop. Really, to productionize these things, I guess one could use a notebook, but I would not personally use a notebook for production workloads. Thank you, Fazil. Okay, if there are no other questions, I will end the stream. Awesome, thanks again. Hope you learned something, and feel free to reach out. Oh, see someone in chat. Currently just exploring deep diving in AI. Noticed models are not great, if not specialized, as they tend to hallucinate. Yes. So I want to get more info about compound AI in this presentation. Yeah, this is a great point. I mean, fairly unsolved problem, I would say. A lot of the secret sauce of all of the various AI companies cropping up over the past few years is, it's a lot of stuff. It's UI and UX, but I suspect part of the IP there is the prompts that they use and how exactly they wire different models together. But yeah, if you ever, when you start getting your hands dirty on these systems, is when you realize that, you know, this there is a fair amount of hype because these models are not as intelligent. Like they're very good. They're very impressive. But yes, the error modes and the hallucinations are, I guess at this point, not surprising, but they're surprising if you expect them to always work. Um, but yeah, typically, system prompts are where you would specialize these things. One is one way. I mean, it's not a foolproof way, but you're a world-class podcast writer is one way you can get the model to sort of focus on a certain area of domain that it's been trained on. Okie dokie. I will hop off now and end the live stream. Thanks, everyone. Have a good one.